All right, now this recording is for section 3.5, arithmetic and algebra of functions. Now some people say arithmetic, but it's arithmetic, but anyway, it doesn't make a difference. It's a word. Now, to get into domains here of functions, because when you're doing adding and functional analysis of these functions, and that's composite functions and such, you have to be always concerned about domain restrictions because you're dealing with fractions or whatever. So you just got to think about what it is you're dealing with. Now, we talked about domain restrictions. Again, domain restrictions are all about the idea of what you can put into the equation as far as x values. Domain is related to x values. So input creates output. So functions are all related onto these concepts of input and output. And the functions themselves have restrictions. For example, for this particular one, we have a fraction for number one. So you can't divide by 0. That's a restriction. So what you do is with any fraction, you set the denominator equal to 0 and you solve for it. All right. Well, so x equals 5 means that when we go ahead and put 5 in there, 5 minus 5 is going to equal 0. You can't have that. So the domain, and the way you put it in interval notation is you skip over this. I mean, we talked about this in other lessons, but you take and go from negative infinity to 5. You unionize it with 5 to infinity. All right. So that's how that works. So that's the answer we're looking for. Boom. Okay. So now, when you're looking at quadratics is a parabola when graphed. So this one, of course, because there's a negative inside or in front of it, is inverted. And by the way, there's no offense by putting it into a graphing calculator if you feel like that's necessary. But when you look at this, there are no restrictions because you can put whatever you want for the domain. All right. So that's the answer, is from negative infinity to positive infinity. That's your answer you're looking for. All right. So we look at that as for all quadratics, it doesn't make a difference. It's always going to equal the same exact answer for the domain. Now, of course, we're dealing with fraction here. So guess what we're going to do? So the denominator equal to 0. So when that comes to the process of this, then there is then the issue of do you know how to factor? All right. So when we're setting this equal to 0, we're going to have to factor. Now, how you do this, okay, and this is the way I've been trying to instruct you, is you take, it's called the AC method. So you take this, you do 7 times 24, get 168, and you're adding two numbers together to create positive that add up to negative. So it's going to be automatically 2 negative numbers, and they're going to have to be pretty close together. So we take 168 and let's just say divide it by, I don't know, 18. Let's see what happens. Divide it by 18, and it gives you 9. I mean, I just chose something out of random. So they're dividing it, right? And just it's not going to end up being divisible by 15, but you're trying to see what numbers will work. Now, there is another strategy for that, and it will, this one worked. It's 12, and 12 and 14 works for 168. That multiply together to create that. But then if you add them together, that's 20. That's going to give you 26, and not quite the answer that we're looking for. All right. So we're going to try a couple of different combinations, but that doesn't work. I mean, so it doesn't look like we are finding what we need to find in order to get those, what we need. So what we can do is choose to, I mean, because I'm getting exhausted trying this. I mean, I can go ahead and choose the quadratic formula if I wish. I mean, that's another strategy, because I seemingly can't find what will work for this. I mean, I know, like, I could keep on trying, let me see. Yeah, of course, 14 and 12, right? So those are the two closest numbers that would equal that, and I can't seem to find it. So what I'm going to do is just, if I'm getting frustrated, is just take and do the quadratic. I mean, there's no harm or foul play in that. So I'm just going to do this. All right, so I'm walking through the quadratic right now. Nothing I should be doing, or anything I'm doing right now shouldn't alarm you. I should have wanted this thing. And perhaps I'll find it. Yeah, probably some of you already found it. I mean, good for you. Right now, my brain is not working properly. Probably. So here I'm curious as to find out what the heck that is going to be. But anyway, I mean, this is just one strategy, right? There's one answer. Now I got to reduce it, of course, but then I'm gonna get there. I mean, I don't worry about things, guys. I just do what I got to do. And if you don't know how to run the quadratic by now, there's something wrong. All right, so I'm curious as to why that didn't work out. Really easy. I couldn't find it real quick, so I just bailed on it. I get tired of sometimes dealing with it. Anyway, this is 8 and 7. All right, so we have the answers for this. So now, when we look at this, all right, x equals 3 and x equals 8 over 7. So now we're looking at the values of which it can't equal. So this is like 1 and 1/7. So we're looking at then from negative infinity all the way up to 8/7, and it's going to jump over that value and go up to 3 and pick up from 3 onto infinity. That's the answer we're looking for. So I got there. It took me a little longer than I wished. But notice how I didn't worry about the numerator. All right. Now, some of you will find factoring a little bit troubling and perhaps had to do this. Okay. Quadratic formula is not the easiest approach to it. I just, I bailed on it because I couldn't find the two numbers that multiply together 168 that added up to 29. It is what it is. Okay, so let's go ahead and continue. All right, now you're doing this repeatedly, where you're with these fractions, they're constantly giving you fractions because they know that you have to set the denominator equal to 0 and then have your factors. So some of them are easier than others. Like, for example, this one is 5 and 4. That's pretty simple. So you have positive 5 and 4. All right, and then you go ahead and find that it's x equals -5 and x equals positive 4. So you go ahead and go from negative infinity to 5, that's negative, and then jump over that negative value, and go to 4, and then jump over that value, and go to infinity. Okay, so that one's pretty simple. All right, like I said, some of them easier than others. Now, when you come up to this, find the domain, again, look at just the denominator. I mean, so x cannot equal -5, nor can it equal 6. And I'm done. I don't have to worry about anything else. All right, so I'm just going to go ahead and write it. So -5, jump over -5, go to 6, jump over it, and done. So that's my answer. All right, you just got to jump over the two numbers that are going to create zeros in the denominator, right? We don't even care about the numerator. Now, remember the domain restriction on a radical is that it has to be 0 or greater. I mean, it has, x has to be greater than or equal to 0. So what you do then is set the contents of the radical. You set that greater than or equal to 0, and then you solve for it. So then I go ahead and do that. I'm going to get negative. All right, -6, and then I go ahead and add 9. Divide both sides by -6. And that switches my inequality. And then so I get negative, and it's 3/2, because 3 reduces that, right? So now I got to go ahead and just say, well, it's all values that are x is less than or equal to -3/2. So it's going to be negative to this, inclusive. Okay. So that's how that works. All right. So we got that one done. Now, same thing goes for all of these, right? So you're just looking at setting, figuring out what the radical is, and then, seeing what value systems that you can have in there. Okay. Now, sometimes it's helpful, perhaps, to graph them. I mean, look at this one. Well, I'm not going to worry about this one. This one you got. All you got to do is set the contents of the radical greater than or equal to 0. I'm going to let you do that one. Okay, here's what the answer would be. I mean, I could tell that answer right away, but I'll let you figure it out. Now it says find the domain of the given function. Now, there's a reason why they're giving you an odd and then an even index. Okay. But sometimes students get confused when it's like that. So I'm going to go ahead and show you what it's like on the graphing calculator. All right. I mean, nothing wrong with that. So let's go ahead and show you how to do that. Now on this calculator, when it comes down to it, you can choose 5, and it'll allow you to change the index level, that thing that's in the box here that's the index. It's right next to the radical sign. And then you're going to go ahead and do 3x minus 2. All right, and then we have that. So let's go ahead and graph that, see what that looks like. When you have an odd indexed radical, domain is all real numbers. That's it. So it's negative infinity, positive infinity. All right. I mean, and that's indicated by the fact that you don't have any restriction there. So any odd valued radican, or valued radical, you go ahead and put negative infinity, positive infinity. Now, but when you go ahead and take and do an even index, okay, which is 8, and it doesn't matter what the contents, well, it does, but the thing is that you're going to have some restrictions. Okay. See, and you have that, and you graph it. Look, you do have restrictions on that, because even, okay, you can't take radicals of even values, right? Or negative numbers, I should say. So this is where, if it's even, you set the contents of the absolute value greater than or equal to 0. And then this gives you 2x -4, and then x is greater than or equal to -2. Okay, and that's where this is showing from. It's -2. It's hard to see on your screen, I get it, but you can punch it in your own graph calculator. Okay, so we're looking at then interval where it's from -2 all the way to infinity. That's how you would indicate that. Okay, so domain. All right, I'm going to leave you guys to figuring out the rest of these. It's the same concept over and over again, just figuring out what the domain restriction would be. Now, if you come up with systems like this one, for example, where you get I, the answer is all real numbers. I mean, I can tell you that. Like, what you're going to do with this one right here is you would go ahead and do 36 plus this and set it equal to 0 and solve for it. And then you take the square root of both sides, but you're talking about square root of a negative value. So it's going to be x is greater or equal to plus or minus 6i. That's, who cares about that? So it's all real numbers. You don't want to worry about i's and such. But when it comes down to something like this, then you should be concerned, because that one, watch this, it goes like this. You divide both sides by negative, and then you square root, and then you get plus or minus 10. So x is equal to plus or minus 10. So you'd have to jump over those two values, and they will right here. Okay, so yeah, recognize that. They put it in the same question for a reason. Okay, I'm gonna let you guys continue to work on this. Like, this is a restriction, and you know what? You have to think about the most restricted value system. Okay, you have to throw both of them out. Okay, you just have to think about whatever it takes to make it. So you set it equal to 0. You set the entire system equal to 0, and you solve for it. All right, and then you go ahead and then take and set the restrictions for the radical. So there's going to be two different parts. And some of you are like, I need you to show me. I need you to show me. Really? Do you? I mean, can't you attempt to try to figure it out yourself? But I'm going to show you. I mean, but there's a video here to help you. But you need to wean yourself away from your instructor teaching you or showing you how to do it. You got to challenge yourself. So go ahead and subtracting 5 from both sides, you get the following. And then dividing both sides by -1. And then squaring both sides. Subtracting 9. And then dividing by 2. Okay, so now we have that. So x equals 8 is one answer. Now I got to figure out the other part. So I'm thinking about that, and I'm putting that on the back burner. Now I need to go ahead and set 2x plus 9 greater than or equal to 0. Okay, and then I'm going to solve for it. So then the value is x is greater than or equal to, and then I'm going to subtract 9, get -9, divided by 2 gives me this. So now I'm going to have to put in an inequality or an interval notation as from -infinity all the way up to -9/2. Jump over that one, unionize it with -9/2, all the way up to 8, and then jumping over 8, and then picking it up to negative or positive infinity. So that one's going to be a little different. Okay. Now the thing is that darn it, has to be greater than or equal to negative 9/2, right? So we're thinking, all right, why not this? Because that would break this. All right, so this is a throwaway. All that's a throwaway, and you could be equal to this. So this is why that's restricted to just this component. And I wanted to purposely put that because we are talking about two value systems, but remembering that this has to be greater than or equal to that. All right, not just equal to it. And I wanted to point that out. So this is our why this occurs, why we don't include this. Okay, so just think about that for a second. And so thing is, set this equal to 0 and then set the restriction. Whatever is the most confined restriction is what you take. And that's what this was about, is taking and throwing out the most restriction. Okay. So I'll leave you that. Now I'm getting into the function operational values for this. And we talk about domain because so much because now we're operating on this and we're thinking, okay, if I go ahead and add this function to this function, all I'm doing, and this is pretty easy, by the way, when I'm taking and adding these together, this is the basic construct of that. I'm adding these together, so I'm adding this together, I get negative 5x, and then I add this together, I get positive 5. All right. And so that's the answer we're looking for there. Okay. But now the domain restriction on this, is pretty straightforward. It's both of them have negative infinity to positive infinity. So then the resulting value system of the domain is going to also be a linear function, and that's also from negative infinity to positive infinity. So we're done with that. Likewise, when we do subtraction, all right, we're taking the function of f of x and subtracting the entire function of g of x. Then all we're doing is just changing the signs of this, and we get negative 13x, and then we're going to go ahead and get positive 25. But then our domain is not going to change in that. It's going to be from negative infinity to positive infinity. Now, when we do multiplication, it's going to be the same concept as what we just did. All right, but now we have two binomials that we multiply together, which creates a trinomial. All right, and that trinomial then looks like something like negative 36x squared, and then this is going to give us negative positive 90. Yeah, positive 90 x, and then this is going to give us positive 60 x, and this is going to give us negative 150. And then we add these two together and we get 150 x, and then the rest of it stays the same. So here's the answer for that. All right, so it's the same thing, negative 36x squared, 150x, and then negative 150. All right. Now, if we remember, what is the domain restriction on a quadratic? There is none. So we would have the value of negative infinity to positive infinity. Now, when we're looking at division, then it's negative 9x plus 15 over 4x. Now, we're going to go ahead and think about, well, we could take out a 3, a negative 3 that is, and get this. Okay. And then we could go ahead and factor out a 2. All right. But we notice that, hold on, yeah, factor out 3, I get 3, I'm sorry. Gotta put the right answer in there. Yeah, sorry. Okay, now, but here's the thing is that we can't reduce anything. There's nothing we could do here. So the only thing that we could do is think about what we can't put in the denominator here. So the answer for the f of f divided by g would be, in fact, this answer right here, because there's nothing we can factor out and clean up a little bit. But then we go ahead and set the denominator equal to 0 and get positive, what is it, 5 over 2? So 5 over 2 is going to be a value we need to skip over. So we're going to do that, okay? And if you're sitting there scratching your head and thinking, how did I get that? Then you weren't listening to anything else I was talking about as far as setting the denominator equal to 0. All the work I've done is just flying over your head. And it doesn't make sense why that's happening. But some of you are just freaking out about all of this. You think math is so hard, and you can make it hard if you find that this is happening to you where you can't figure this out. All right, so this gives you this, and then 5 over 2, right? Because you simplify it. And then you just skip over that value by going from negative infinity to 5 over 2, all the way to 5 over 2. Not really, not all the way to that, but all the way to positive infinity. So you're skipping. This is a way of skipping over 5 over 2. Okay, because this is 0. So that's the answer we're looking for there. Now this process continues, and I'm not going to do all these questions for you. You're going to have to figure this out. And if you can't, then you need to reach out. And and you can also watch the video here that goes and accompanies how to do a problem like this. Okay? So you have restrictions, you have to follow through and do what you need to do to get through it. But this is what you're looking for, and this is what you end up getting. Okay? So I mean, I don't need to go over this with you. If you think I do, then you are just becoming too dependent upon me. But that's what we're looking for. All right, now you got to think about the restrictions. Like here's a restriction. That's where you have a situation like we had over here, where we had a value system that we needed to concentrate on and throw out values that are involving radicals that are not greater than or equal to 0. Okay, got to think about things. All right, so. And that's what, see how you get these answers where it's from 0 to infinity, because that's a restriction on that structure of the radical. And it seemingly falls true on all of them that you're greater than or equal to 0. And this one, however, has even more restriction because of the fact that you can't divide by 0. Okay? Or, have a 0 in the denominator. And again, there's a video that supports that. All right, so you have that. Going through this one gets a little bit scarier because there's fractions involved. Okay, but adding them together, they're not hard because they're common denominators. So add the common denominators together. All this has been instructed to you before on how to do this. Now, if you're stuck on it, look, let's take a look at the answer. These are the same. So because they're the same and you're adding these together, the bottom just stays the same. But then you go ahead and do, well, negative x plus negative 2x gives you negative 3x. And then 10 plus negative 9 gives you positive 1. And then that's it. And then you have the domain restriction of plus or minus 4, so you have to skip over those two value systems. So likewise, the same thing occurs when you're doing subtraction. And then you get the same exact restriction. And then you're talking about multiplication. So when you multiply them, you're going to get this for a squared and everything else. And then you have the same exact identical restriction. And then you're doing division. And when you're doing division, you're stacking fraction on top of fraction. So actually, it works out pretty easily with these when you're doing the g of x on the denominator. Then it reciprocates, and you put it on the bottom, and you put this on the top. It's pretty simple because these will cross out each other when you divide. And I'll let you work on that. This is stuff that's review, actually. This is seriously review. It's just a matter of you remembering how to do the reciprocation and everything. So All right. So I'm going to let you guys have that. Now I'm going to talk about fog. All right. Just need to talk about that for a second. All right. Just give me one moment. I need to do something real quick, as this is something that I need to do from another project I'm on. All right, let me come over here. You got to give me a second. I want to continue with what I've been talking about. It's just I got to get on to something. Hold on. All right. All right. Now, this right here, it says we're talking about fog. Okay. And fog is what we call a composite function. All right. And composite functions is where you take the one function and you insert it into the other function. Okay. Now, I want you to recognize that you're taking whatever the second function that's called out, like G, you're putting it into F. That's what that means. So let's take a look at what that looks like then. All right. So if I have a function of f of x, and that looks like negative 2x minus 4, and then I have the function of g of x equaling 9x minus 9, I'm going to insert it where that x is inside the function of f. So I'm going to have negative 2, open parenthesis, 9x minus 9, and then the minus 4 is part of the problem of the f of x, right? So wherever there's a variable, I replace it with the other function, okay? And so now I just do the distributive property, and then combine like terms, and then that's simple. So it's negative 18x, and then these come together as positive 14, and that would be our answer for that. All right, we're done. So then it takes and does the same thing with respect to now taking the f and insert it into G. All right. So when we're looking at that, it's a matter of taking inside of G, replacing the negative 2x minus 4. And then we'll get negative 9. So now it's a matter of distributive property. All right, this is negative, yep. And then you have negative 9, and then you continue on, and you get negative 18x minus 45. Okay, so there we have what I call golf. You have fog and golf. All right. Now, of course, they're showing here that what you can do is take the function of f and insert it into itself. So it's double time, like it's doubling itself basically, but it's not really. But you're taking and inserting f of x into itself. So then it's nothing different than we've been doing. We do the distributive property. It gets repetitive. I mean, I can't express that enough. It's kind of boring at times because it's like there's a lot of stuff it's the same thing, and it's not hard to do at all. All right, so it's like that's all we have there. And then the g of x, you put it inside the g of x. So take 9x minus 9 and insert it into the x, and then do the distributive property, combine like terms, and that's what you get. Now, but wait a second. We get this value, like we've already done fog, right? Fog is right here. So all we got to do is insert negative 10 into that function we already came up with. So negative 18 times negative 10, and then plus 14. So then this gives us positive 180 added to 14, which gives us 194. And that's what you're going to get for that one. Okay, 194. So all you're doing is inserting this into the equation we already came up with. So we already came up with fog. or golf. We came up fog and golf. All right. Put 2 into the function of the g of f. G of f. All right. So now this is going to give us, what is that, 36? That's negative. And then we add that together. All right. Negative 81. So really is pretty simple. Okay. Fog and golf. So you continuously do this process where you're inserting one into the other. Now, some of them get a little bit more difficult than others, where you get like you get some problems where it's harder. All right. But no worries. All right. You just take your time, put it into both of them. So I'll do one more to show you the consistency. So f of g, all right, meaning I'm going to insert g into f. So where do I see a variable in the function of f, I'm going to replace it with x minus 9. And see, parentheses help a lot when you're doing that, okay? Now, we want to go ahead and do the foiling process and things like that. So, make sure you know how to do that. But there's a little trick when you're foiling out a perfect square. You just go ahead and square that, multiply them together and double it. And then multiply that against itself, right? So you get 81. And then go ahead and put plus x minus 9. So we simplify that a little further, and we get the following, all right, where we take and add these together and get negative 17x, and then add these together and get 72 positive. All right, so we get that, and there's our answer for that. All right, now look at what they did. Now, I assure you that the answer I gave you was in fact correct. I don't know what this is about, but perform the indicator operation simplified. So you're telling me is that I had to just do that? Come on, that was too easy. All right, so anyway, this is what it should come up to. They're not really doing it the proper way. I'm not too happy with what's going on here. The f of x into, this looks goofy. I don't appreciate this right now. I'm going to go ahead and do all these answers. I just don't appreciate this right now. X squared, and then I'm going to come down. Okay, I'm going to put in negative 17x plus 72. All right, and then this one, remember g of f means put the function of f of x into that's what you should get for that one. I mean, that looks so goofy. I don't even know what's going on with this one. Oh, I guess it's the same. Okay, it is the same thing. They're just putting this one in there. That's so weird. I don't know why they're doing that. So anyway, it's the same thing. I just didn't see it. It looks kind of goofy to me. All right, so we have plus that and minus 9. All right, now f of f is going to be just inserting it into itself. So we're going to get x squared minus or plus x squared, and then plus x squared plus x. So now we're going to go ahead and do the same thing we did before, where we're going to just multiply and double it. All right, and then we're going to go ahead and do this. So we're going to get final answer of this. Okay, that was kind of a long one. Let me see if they came up. Yeah, they're not doing it the way it's supposed to be doing it. I don't understand. So I'm going to put the answer in the way it should be. I mean, but you know what? Hey, if they allow you to do it that way, maybe you could save yourself some time. But the answer I'm providing is in fact correct. And now what I'm curious is to whether or not they accept the answer. And now I'm going to have a discussion with somebody if I have to, because everything I'm doing is in fact the proper thing. You're supposed to simplify everything, right, in math? So that's why I'm a little bit concerned about this answer, why it's not showing the proper way. All right, now it's G of F. I'm going to put that over here to say some, I can actually do it this way too. All right, am I being ultra conservative with paper? Now, take G of F, put wherever you see an X, put the X minus 9. And so your answer is going to be, this one's a lot easier because of the nature of the problem. So let's see that one. See, I mean, the answer is the same thing. I just don't know why they're putting it like that. So it's kind of weird. That's why I'm doing it all. Now, we already have this function, f of g. So you're going to go ahead and we have it right here. So you're going to put wherever you see an x, you're going to put the -3. So -3 squared is 9. And then you have -3 times 17. Now, I could do that in my head of 41. All right, it's not 41 actually, it's 51. All right, and then we have plus 72. And then, you know what, just for the sake, I mean, we could just drop it into our calculators, I mean, to keep it simple, but I mean, I'm just doing it real quick. Plus 9, that gives us 30. So our answer should be 30 here, and it's not. So what am I doing wrong? I'm going to go ahead and double check. Maybe perhaps I have, oh, yeah, there's my problem. Is that this should be positive, and that's my problem. See, I made a mistake on my error. My sign, because -3 times -17 is positive 51. And so when I did this, this should be added together. And then adding 9 to this gives us the 132. 132 is right. That's the right answer. All right, so I just went ahead and made a calculation error because -3 times -17 is positive 51. I was too busy multiplying 50 or -3 times, or I was multiplying 3 times 17 in my head, and I was too busy thinking about that number versus the sign. So that teaches you don't do things in your head all the time. It's nice to just drop in calculators and such. Okay, the last one is the GOF. We're going to put 9 into this one. 9 squared is 81. And then I'm making sure I watch my signs now. And then we have 9 minus 9. These cancel each other. So you should be leaving you with 81. And in fact, that's true. Now, there's a couple videos here that support all this, because there's definitely a need to make sure you get it right. Now, I'm going to show you that my answer is in fact right. So submit all parts. See how I got 1 for 1, or 1 of 1? So the answers I provided to you are in fact correct and more appropriate than these ridiculous answers that I'm showing you here. That's ridiculous. Some of these answers, the way they're showing it, I wouldn't agree with it. All right, so do it the way I did it, okay? Please simplify all parts when it comes down to composite functions. All right, so let me Let me make sure that, okay. Now, composite functions, this is another way of writing composite functions. You're putting g of x into f of x into g, f of x into f, g of x into g of x. And then you're now substituting in -3 into that function value system. -5 into the function of f of f. So that one, once you get the answer. Okay. So there's a video with that, and I'm just letting you have some time. I've already now instructed you on how to get to composite functions. I've done now 2 of them for you, and there's video support here along with it. You should have enough material to be successful in this. And of course, make sure you're watching your signs as I have demonstrated. Okay, so that concludes this lesson.